My name is Gavin Hayes. My talk right before this was on getting away from linking native code in Perl, and this one is a little bit in the opposite direction, as it involves building custom builds of Perl. Let's get started. Working with Perl as a Perl developer is great, but often not so much as an end user. Before I even started programming in Perl, every once in a while, looking for a free utility to do XYZ, I'd come across CPAN and have no idea what to do next. In a world taken over by web apps, it's difficult to get someone to download your software, never mind complete a multi-step installation process that installs a programming language and compiles native code. Strawberry Perl, wasn't supposed to read that. Just for an example, if I wanted a Windows user to run my script, they would need to find which Perl to use and install it, start up a shell with the correct path, use a CPAN client such as CPAN-M to install the package, wait, and possibly have the install fail for a variety of reasons. This isn't a dig at Strawberry Perl. I appreciate their efforts to provide Perl binaries on a system without a native package manager. However, installing a Perl module requires far more than what the average user can do easily, especially on Windows. In terms of usability, what works is binaries, especially self-contained binaries that link all non-system deps statically. This doesn't have to necessarily be a static binary. Just with a self-contained binary, there's no need to fuss with an installer, package, or archive. You just download it and run it with a chmod plus X sprinkled in on Unix systems. New programming languages such as Go and Rust have settled on static linking most dependencies, so they can often be installed just by copying over the file to compatible systems. Here we see the output of readelf on the Xism binary. This is a Golang binary targeting Linux AMD 64 systems that use the GNU-C library, more commonly known as glibc. Its only direct dependencies are glibc libraries. This binary should work on any AMD 64 Linux system with compatible glibc, at least assuming it doesn't directly use any syscalls not available on older Linux. How can we build self-contained Perl executables so Perl doesn't have to be a second-class citizen to languages that build to static binaries? The traditional tried and test solution is to use PAR with PAR Packer. A Perl archive, or PAR, is a special type of zip file that contains Perl modules, scripts, native shared libraries, and more. PAR Packer creates a PAR and uses it compiled with your Perl executable in order to create a self-contained binary. If you're running a lot of identical systems or Windows systems, in theory, this works really well. Where this doesn't work so well is when the Perl executable and shared libraries are incompatible with the target system. This happens even within the same operating system. If you pack on a system newer than the target system, it could be dependent on having your system's dependency or newer. The infamous case of this is a dependency on glibc. If you support a variety of versions of various operating systems, this quickly becomes a huge hassle as builds need to be done on each of the target systems. You could set up GitHub Actions to do this, but if you've used them, you know how much fun it is to troubleshoot build fails on the platform that you're not using. What if we didn't need to build a separate executable for each platform? A few years ago, we virtually had all server and desktop systems on the same architecture, x86-64, also known as AMD 64. Forget about Apple Silicon and ARM64 for the moment. I promise I will cover it later. If everything is AMD 64, do we really need separate binaries for every system? Studying old code, Justine Tunney noticed Thompson shell doesn't require a shebang line, so it could be combined with Mark Zabowski's initials. As most shells have backwards compatibility with Thompson shell, a Unix and Windows polyglot executable format is possible. With this information, we don't need separate binaries for each platform. She took this information and ran with it, creating the Cosmopolitan libc. With the Cosmopolitan libc, we can compile C code to a binary that runs on Linux, Mac, Windows, and the BSDs. In short, how I got Perl building with Cosmopolitan was through a trial and error process of figuring out the incantation of flags to pass to configure, to build and link with Cosmopolitan, running make mini test and make test, making patches to Perl and Cosmopolitan, and repeat. Perl's tests are great at finding bugs and were especially useful for finding issues with Cosmopolitan. Getting a working build of Perl with Cosmopolitan was nice, but alone that doesn't really solve our problem of creating self-contained Perl executables. Cosmopolitan binaries are always statically linked, but the Perl modules are not compiled into the binary and would need to be shipped around with the binary. In order for the Perl modules to be findable, they must be locatable at the same compiled paths, or it must be a relocatable build of Perl. Cosmopolitan libc provides a convenient solution to this problem. Actually portable executables are also zip files. For easy access in programs, the magic path of /zip is mapped to the zip file system located in the currently executing binary. We can configure and build Perl with a /zip-based prefix and then pack all the Perl modules inside of the binary. We now have Actually Portable Perl, a self-contained build of Perl that runs everywhere. To realize our original goal of creating self-contained executables for scripts, we not only need to build and pack Perl with modules and scripts, but set up Perl to auto-run a script at startup. To do so, I hacked Perl's argument parsing to instead run a script under a few different conditions. The most flexible method of specifying which script to execute is done by overriding argv0. This is commonly done by renaming the executable or creating a symlink with the same name, or with a different name, but can also be done at exec time. For example, renaming perl.com to perldoc.com or perldoc causes APPerl to execute the /zip/bin/perldoc script in the executable instead of normal Perl executable behavior. Due to various potential portability issues with overriding argv0, alternatively, the APPerl script name environment variable may be set to the name of the script you want executed from the zip file system. If the default behavior of running Perl like normal is undesirable, the binary may be hard-coded to run a default script. This snippet of JSON is used to direct binary patching of a static buffer in the APPerl binary. In this case, it makes perldoc be ran by default. I'll talk a little more about this config system in a moment. Having all scripts and core accessible is nice, but you might be wondering, how can you actually use this to package up your own scripts? The easiest way to build custom builds of APPerl is APPerl APPerl Manager, a CLI utility for creating custom APPerl builds. It handles downloading the Perl source, downloading the Cosmos CC compiler to build with the Cosmopolitan libc, and is able to configure, build, and pack APPerl. My occasional pet project is Media HTTP File Server, or MHFS. Mainly for learning reasons, it doesn't use one of the many great web frameworks for Perl, and instead has its own pull-based event loop. It also handles processes and pipes the Unix way, and it's incompatible with the Windows port of Perl. This is the APPerl project config for MHFS. It consists of one target config titled MHFS and is based off of the full Perl target, and the final executable name is mhfs.com. As it includes more than a default Perl installation, it installs some non-core modules off of disk: HTML template, URI, class inspector, file shader install, file shader, and finally APPMHFS, the server program itself. The install modules feature is able to install ext utils makemaker using distributions and handles relinking the binary. Here's a demo of running MHFS on Windows. I start the server and connect to it in a browser. Start playing a song, and after a moment, I seek forward in the song. Command prompt isn't a big fan of the verbose Unicode logging to standard out, but it works. I have my computer's audio muted to potentially getting this presentation muted by YouTube's DMCA algorithms. On the roadmap for APPerl, I'm planning on a few things. First is ARM64 binaries. Cosmopolitan supports ARM64, and only a few paths should currently be hard-coded to x86-64. So I expect this to not be hard, but we'll see. This is important so we can support modern Macs without Rosetta x86-64 emulation. I don't have any ARM64 handy yet, but I plan on getting some. Once we have ARM64 available, we should be able to make fat binaries so the same binary can be used natively on both architectures. This shouldn't double the size, as both arcs should be able to share the same zip file system and thus the same non-arc dependent Perl modules. Now, having APPerl work natively everywhere, would be a good time to update the patches to Perl to make 5.38 and 5.40 binaries. It's currently stuck on 5.36.3. After cleaning up the patches a little more, maybe the Cosmopolitan libc platform changes could be merged into upstream Perl. This wouldn't include actually portable Perl features like the script execution changes or the binary with modules included in the zip file system. Just building Perl with the Cosmopolitan libc. As a bonus quality of life add-on, it'd be nice to have easy transport layer security support. OpenSSL can be built with Cosmopolitan and works, but no work has been done to see what it would take to integrate with APPerl. I'm especially not in a rush on this one, as it'll be likely affected by the efforts to get TLS support into core. Thank you all for coming. To build your own versions of APPerl, you can find the Perl dist APPerl module on CPAN. On the APPerl webpage linked on this slide, you can find links to binaries, the code repository, the original making of write-up, and the Cosmopolitan libc Discord server for community and help with APPerl. Any questions? In the back?
So you mentioned in your last talk that syscalls were giving you trouble. Does Cosmopolitan have any gotchas with regard to syscalls and portability in that regard?
So the question was, does Cosmopolitan have any compatibility issues between syscalls of different platforms? And yes. There are some issues, but if I can find the Cosmopolitan webpage, there's a compatibility table. All right, my resolution isn't the best for showing this off, but essentially it shows tons of syscalls and like where it works and where it doesn't work, or if it half works.
What's %GS?
I have.
Is that row the whole %FS?
Thread local storage, the GS register or segment register. I don't know much about it.
they're skipping the official APIs to access TLS and going straight to assembly of what it really is under the hood. So the OSs are just flip-flopping on the decisions and using FS or GS.
Yep. Yes?
I was curious if you could talk a little bit more about the shell script format and how those pieces fit together in more detail.
I was asked like how to explain a little bit more on how the shell script and pieces and executable parts fit together for like how execution starts. I don't know if I have much more to say on it. It's on Unix systems. It's just treated as a shell script, and most shells were already working with it, but in the few cases they were, patches are made to like ZSH, for example, so that it could run it more easily. And additionally, part of Cosmopolitan is an ape loader that the shell script is actually installing this executable loader. And you can set up your system with like bin format to use that, and so it doesn't even have to go through the shell. Anyone else?
Did I see in the start it's both Linux, UEFI, Windows, and it's even UEFI compliant, this binary?
Oh wait, I think I'm in the wrong presentation. That's what.
Too many times.
It was there.
Oh, okay, this slide? Or?
The one before, the loader, yeah, that thing.
Yes, some actually portable executables also boot bare metal. But in practice, it's not easy to create one that works with it because not very many syscalls are implemented for bare metal.
So I didn't know, I've never heard of Blink.
Blink is just a system emulator. Justine wrote her own, felt like QEMU was too heavyweight, and so it was originally how Cosmopolitan was, how she planned to run Cosmopolitan on ARM systems. And Blink is fairly fast, but not fast enough for doing AI, and so she ended up making a port to ARM. Yes?
Do you know if she's considered CYG Lin or MainW?
I'm sure she's used those things before, but
Windows anyway? Well, it's all statically linked, so why would you run?
Sync would just introduce more external dependencies. This is for OSs, not emulation layers, except for the ARM case, where you have to translate instructions guaranteed.
Well, I suppose you could statically link into some of others too.
Well, fat packing, he already said there's fat packing in on the table somewhere.
I mean, MainW, it has a lot of bugs. It's not built with the universal CRT. That a regular Microsoft build would use these days. So that was just, that's why I was curious. But found out that the hard way.
Yeah, I think why Cosmopolitan tries to be as standalone as possible, not depending on things like that. And so as much as possible, it uses the exact same instructions on each operating system. And so it's only really the syscall layer that it dispatches off to whatever syscalls or the Win API. All right, thank you.